Hey everybody, video number 7. Today we're going to dive into this thing called isomers. And we've actually touched on it a little bit. I've tried to draw it for you a few times without telling you what it is, and today we'll formally discuss it. This picture is a perfect example again. Notice that there's the same number of carbons, hydrogens, and oxygens. The only problem with that picture is you got to know that every time the line crosses, there's actually a C in there. And I think that we can get there with what we've done. So officially, right, an isomer has the same number of each atom, but a different arrangement in space. That different arrangement in space gives it a different name, different properties. In this case, there's different functional groups. I see an alcohol on the end, I see an alcohol in the middle, and then I see an ester or an ether. That's an ethyl methyl ether. Okay, so the molecules have the same chemical formula, but they will have different names and different properties. The different properties come from the different structures. So you might need to write that specifically if that doesn't make inherent sense to you. The different structures is what gives it different properties, not necessarily different names. The different structures give it different properties and a different name. So a quick example, I'm going to have to do some writing on the board because I'm not animating this guy. This would be a little much. But anyways, we're going to start with the simplest chain with 4 carbons, and we would call that butane. Okay, I'm going to make an isomer of butane that will still be C4H10. And the easiest way to make an isomer is to do what we did last video in 6 and make a side chain. So what I'm going to do is I'm going to take this off. And in order to make it a true side chain, I have to put it right there. I cannot put it on one of the end carbons, right? And let's be honest, carbon 1, 2, 3, 4. When I take that 4th carbon off, notice carbon 1 and 3 will be end carbons. So if I put that 4th carbon up on 3, all I've done is bent it, and that doesn't work. That's still not an isomer. That is just still butane. It's just a bent butane. So what I need to do is I need to switch this red and the green. So we can do that. I'm going to end up having 3 carbons across the bottom. And then the carbon on the end, I'm going to put here. I'm going to fill all in with my H's. And this H right here is the one that was in green, the first one I drew. And this will have same numbers of carbons and hydrogens. I see 4 carbons, and I see 3. 3 is 6, 7, 8, 9. I see 10 hydrogens. And then we just need to name this thing. And to name it, we name our base chain first. 3 is propane. Prop single bonded is ane. And then on the second carbon, I have a methyl. So 2-methyl propane. And again, I technically don't need the 2 there because the only place it can go is on the second carbon. If you wrote methyl propane, that would be very much okay. All right, sorry, my C's and H's are a little bit sloppy, but I hope you understand what we did. So what we did first is to just make a methyl branch from the chain, which is what it kind of gave us a hint to do. Ready? So next one, I'm going to go a little bit bigger of a, right? I'm going to take pentane. It's got 5 carbons. And I can make 2 isomers real fast from this. The first thing to do is the same thing. So it says just try making a methyl branch. So I'm going to take this guy right here, and I'm going to pop him. Let's say I'm going to put him right there. Okay. So that leaves me with 4 carbons to draw. I'll try to draw slower this time. And then I'm going to put a methyl on the second carbon. And I'm going to fill in my H's. I know why it's animated. Seeing me draw, it's one thing, but it's kind of boring, right? All right, so then I have 5 carbons, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 12 hydrogens. I named the base chain first, which is 4 carbons, which is bute. Single bonded is ane. And then on the second carbon, I have a methyl. And what's nice about butane on these side chains is, again, whether I put that carbon if I put my methyl here, 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 or here, all four of those are still 2-methylbutane. The YL tells me it's a side chain, so it really can only be 2-methylbutane. You would be able to get away with just calling that methylbutane. If you put the 2 in, I'm cool with that, so we know what's what. Okay, so then to make a third structure out of that, what I would do is, let me go back. I'm going to take that end carbon off now and put it on the bottom and make 2 side chains. Okay? Wait, I went back too far, so let's get here. Okay, so now I'm going to have 3 across the middle. And I had the one up top, but I cut the one off on the far right side. I'm going to put that one here. Now fill in my H's. So now my 3 across the middle is my base chain. 3 is pro. Single bonded is ane. And then I have a methyl up top, and I have a methyl down here, both on 2. So that's 2,2 dimethyl propane. And notice it has C5 and H12. So, in summary, real quick before I say we're out of here, we've talked about this a little bit. So I'm looking at yesterday's Bell work for alkenes to do the double bonds. And all I did was move the double bond, and it was technically an isomer. Notice in today's example, I started out with single bonded carbons. So I have to stay single bonded carbons throughout the process of making isomers of that particular pentane. If I had an ene, let's say I had pentene, I could move the double bond, but there would have to be a double bond at all times. I can't add bonds. Adding bonds will ruin the whole thing because that will change the number of hydrogens. So I can't go from this pentene and pentane that we started with and try to get into a pentene, because that's going to change my number of hydrogens by changing that bonding. So if I'm all single bonded between my carbons, all of my isomers will have single bonds in my carbons. If there is a double bond present, then there has to be a double bond present in all my isomers. If there is a triple bond present, there needs to be a triple bond in all of my isomers. Changing that bonding between the carbons will change the number of hydrogens, and we know that from the general formulas in the alkane series for alkenes, alkenes, and alkynes. Changing the bonding changes the number of hydrogens, and we can't have different numbers of atoms and still be an isomer. So that is the real take-home piece I want you to take from this. Other than that, it's a difference of moving some things around and having some fun. And I didn't have a model in class for Bell work. I'll probably have a model. I'll show you in real time how we can just pop things around and move atoms around, and it's the same number of atoms, but I changed its structure, hence I changed its name and its properties. With that, we have success. We know what isomers are now.